Alright guys, we are doing 2.3 and talking about complex numbers. Some quadratic equations have no solutions, no real solutions. For instance, the quadratic equation x squared plus 1 equals 0 has no real solutions because there's no real number x that can be squared to produce negative 1. So if you solve, you need a number x that could be squared to give us negative 1. That doesn't exist. So to overcome this deficiency, mathematicians created an expanded system of numbers using the imaginary unit I. And we define I as this. It's simply the square root of negative 1, so that I squared is negative 1. All right, so, and it follows a pattern, if you will. So I to the first is the square root of negative 1. I squared is negative 1. I to the third is negative 1 times I, or negative I. I to the fourth is negative I times I, which would give you negative 1 times I squared, which is negative 1 times negative 1, or positive 1. And then if I go to I to the fifth, I'm back to 1 times I, which is I. Okay, so it follows a cycle. It goes 1, 2, 3, 4, and then when you get to the fifth step, it comes back to start back at 1, basically, because I to the first is the same as I to the first. And we'll come back to this here in a little bit. But each complex number can be written in standard form, and this is what standard form looks like. A plus bi, a being any number, and the bi part is a number with an I attached. For example, if you wanted to write this in standard form, we would take this and rewrite it as such. We would take that square root and realize that that is negative 1 times 3 squared. That's negative 1 times 3 squared minus 5. All right, so let's clean this up a little bit. Okay, since 3 is squared, I can take it out of the square root. Since I is under there, that's the square root of negative 1. And we know that the square root of negative 1 is I, so 3i minus 5. But standard form means we put the real number in the front. So we would rewrite this as negative 5 plus 3i. So the definition of a complex number. It says if a and b are real numbers, then the number a plus bi is called a complex number. It is said to be written in standard form. If b equals 0, then the number a plus bi is really just a real number. If b is not equal to 0, then the number a plus bi is called an imaginary number. A number in the form bi, where b is not 0, is called a pure imaginary number. Okay, there's no real number attachment to it, so it's pure imaginary. So operations with complex numbers. Here we go. Additive inverse. What it does is it zeroes out the complex number. So if a plus bi is my complex number, then the additive inverse, whatever's going to zero it out, is you take the opposite sign of the a, negative a, minus bi. You basically just change the signs of a and b. Right? So that's the additive inverse. Okay, so here's some examples that we walked through. We're going to first get rid of our parentheses. So let's kind of clean it up. 3 plus 2i plus 4 minus I minus 7 minus I. I distribute that negative. So let's clean this up. Let's take our real parts first. 3 plus 4 is 7 minus 7 is 0. Okay, well those go away. Now look at the I parts, the imaginary parts. 2i, take away an I is 1i, take away another I is nothing. So this one just cleans right up to 0. So let's try number 2. Again, first start by taking away the parentheses by distributing out whatever signs you see. 3 plus 2 minus 3i minus 5 plus I. Okay? So then I clean it up and add like terms. So I have 3 plus 2 is 5 minus 5 is 0. Okay, so my real part is gone. And I have negative 3i plus I leaves me with negative 2i. All right? So that's a pure imaginary number. Looking at number 3, a little more complex. So we're going to rewrite this in I form first, okay? Kind of reducing our radicals as we go. So here's what I mean. We're going to take 5 plus the square root, let's clean this up, that's really negative 1 times 3 to the third power. And then I distribute the negative, that becomes a plus 12 minus the square root of negative 1, and then 48, let's think about this. This is 16 times 3. So we can continue to clean this up a little bit. 5 plus, okay, I can take an I out because the square root of negative 1 is I. 3 cubed, keep that in mind, that is 3 times 3 times 3, right? And if there's 2 of them, I can take one of those out. So really this becomes 3 or 5 plus 3i square roots of 3. All right, now plus 12. Now over here, 16 is a perfect square. We know the square root of 16 is 4. So I'm going to take that 4 out. And we know the square root of negative 1 is I. So I'm going to take the I out. And that leaves me the square root of 3 in there. So if I've cleaned all this up, let's see if I can combine any like terms. Now look at these. They both have a radical of 3. And these are considered like terms. Now I can combine those two. So I'm going to take my real components first. I'm going to take 5 plus 12, and that gives me 17. And now I have 3i square roots of 3, take away 4i square roots of 3. So that leaves me with negative 1i square roots of 3. And there's my answer. So you're going to want to reduce those radicals as much as you can because you can't combine them unless the radical is exactly the same. Okay, and usually they will reduce down to something that's the same. So take your time and be okay with taking up the space to do it. All right, let's try some more operations with imaginaries. Okay, so the first thing you want to do on these is rewrite these in I form, or simplify them in I form. So realize that this is negative 1 times 3 under the radical, and this is negative 1 times 9 times 2 under the radical. Okay, so let's take out our perfect squares. Negative 1 is perfect square now that we have I. So we take I out, square roots of 3, times perfect square. Well, 9 is perfect square, so take a 3 out. Negative 1 is a perfect square, take I out, and I have square root of 2. Now I can multiply basically the outsides to the outsides and the insides to the insides. So I times 3i gives me 3i squared. And 3 plus 2 on the inside of the radical gives me a 6. Well, I'm not finished because it's not completely cleaned up because we know I squared is negative 1. So that leaves me with a negative 3 square roots of 6. Okay, so it started out imaginary, but it came out to be a real answer. All right, and this one, multiplying binomials, we would FOIL this, or you can use box method if you prefer, but if I FOIL this, I would do first terms, 8 outer plus 6i inner minus 4i, and last negative 3i squared. So if I clean this up, add like terms right in the middle, so 8 plus 2i. Now I squared is negative 1, so this is really negative 3 times negative 1, so that's a plus 3. So then I can simplify this by combining like terms, and I get 11 plus 2i. Right? Now, number 6. Square root of negative 10 squared. Well, that's the square root of negative 10 times the square root of negative 10. All right? So a lot of ways you could look at this. You could look at this as negative 1 times 10 times negative 1 times 10. Well, these are perfect squares, so I can take I square roots of 10 times I square roots of 10. Well, I times I is negative 1 square square root of 10 times square root of 10 is 10. So that leaves me with a negative 10 as my answer. All right. If you just take the shortcut and know if you square a radical, it all comes out. That's fine as well. All right, look at number 7. All right, number 7, we're going to distribute that 4i. So I get 32i plus 20i squared. All right, so 20i squared, remember I squared is really negative 1. So this becomes negative 20 plus 32i. We put the imaginary part in the back to make it a complex number in standard form. All right, number 8, a little more complicated. We got to work this one out. All right, remember this is, we've got to square these binomials first. So let's look at this. If I do 4 plus 5i times 4 plus 5i, I'm going to do, if I do FOIL, I have 16 plus 20i plus 20i plus 25i squared. Okay, so that's that first one. And then 25i squared is negative 25, right? So I'm just going to put that there. And then I'm going to subtract what I get when I multiply 4 minus 5i times 4 minus 5i. So I get 16 minus 20i minus 20i plus 25i squared. Again, that makes that negative 25 here. These combine to be negative 40. So I'm going to have 16 minus 40i minus 25. Now to get rid of this negative in the middle, I have to distribute a negative 1 throughout and see what I get. So the first part stays the same. So that becomes negative 16 plus 40i plus 25. Now we go through and combine like terms. So we have 16 minus 16, those cancel out. Negative 25 plus 25, those cancel out. So I have 40i plus 40i, it leaves me with 80i. And that's it. It's a pure imaginary number. All right, so now let's talk about something called complex conjugates. So these two are complex conjugates of one another. Notice A and B are the same. B is attached to I. The thing that's different is that sign in the middle. And these are valuable because we use those to get rid of imaginary numbers. We can solve them out as we multiply or divide. All right. So look at number 9. We're going to multiply two conjugates together. So I want you to see what's going to happen as we do that. So if I FOIL this, I get 1 minus I plus I minus I squared. Well, negative I plus I is 0. So I have 1 minus I squared is negative 1. So that becomes 1 plus 1, which equals 2. So notice it's now a real number. It's no longer imaginary, and that's the beauty of a conjugate. It takes away the imaginary part. All right, so let's look at another complex conjugate. Let's multiply these two in 10. Same idea. Notice that A is the same, B is the same. The only thing that's changed is the sign in the middle. All right, so if I FOIL this guy, I get 16. Oops, sorry. I get 16 minus 12i plus 12i. Negative times a positive makes it negative 9i squared. So the middle terms fall out, and they always should. So I have 16, and then 9 times I squared, that's negative 1, makes that plus 9. So it's 25. Okay, so that being said, let's look at how to write it in standard form when things are divided by an imaginary number. So to write it in standard form, what you want to do is multiply it by the conjugate of the denominator, just the denominator. Okay? So if we write the conjugate of that, we get 4 plus 2i. Okay? We have to do it to the top and the bottom because this fraction right here is equivalent to 1. So it's not changing the value of the original, but we are going to get rid of the I value, or the imaginary component of the answer. Okay? So we got to FOIL the top, and we got to FOIL the bottom, and then clean it up. All right? So let's do the top. So 2 times 4 is 8. plus 4i plus 12i plus 6i squared. The denominator, if I FOIL this, I have 16 plus 8i minus 8i minus 4i squared. So, like I said, the imaginaries fall out of the bottom. We still need to clean this up a little bit. Okay, the I squareds are negative 1s, don't forget. So if I do this, I have 8 plus 4i and 12i is 16i. 6 times negative 1 is minus 6. The bottom is 16. The middle fell out, so it's negative 4 times negative 1 gives me plus 4. So again, I can keep on going. 2 plus 16i divided by 20. Now you would want to simplify this as much as you can. So the way you would think about this is you would split this up. You'd say 2 over 20 plus 16i over 20. So you always want to reduce this. So you make that 1 over 10 plus 16 over 20 reduces to 4 over 5i. So you always want to reduce your answers in the simplest form. So let's try number 12. Same idea. We're going to multiply by the complex conjugate of the denominator. So that's 4 plus 5i, top and bottom. All right. So if I multiply, I have 8 plus 10i in the numerator. The bottom, I have 16 plus 20i minus 20i minus 25i squared. So the middle terms fall out, like I hoped. The numerator stays 8 plus 10i. The bottom is 16. And remember, this is negative 1, so 25 times negative 25 times negative 1 makes it positive 25. So this is 8 plus 10i, so 16 plus 25 is 41. So if I split this up, I then have 8 over 41 plus 10i over 41. And then I look, and I really can't reduce that, but I have at least gone this step to investigate. All right, last couple of examples for you. We're going to just put these in standard form. Okay, remember what standard form looks like. It looks like a constant, just a value, a real value, plus an imaginary value. Okay, right now I have two imaginaries, and we need to make it in standard form. So what you would do is clean this up a little bit. Okay, so I would rewrite it like this: negative 6 times I squared times I, right? Plus I squared. Well, we know that I squared is negative 1. So this is negative 6 times negative 1 times I plus negative 1. Right? Well, negative times a negative is a positive, so this is 6i. And this is just negative 1. But that's not standard form. You put the real part in the front, so you would put negative 1 plus 6i, and then you're done. Okay? Now, 14. Square root of negative 75. So I would stretch this out. Negative 75 times negative 75 times negative 75. All right? So let's continue to simplify this a little bit. We know that the negative is under the radical, so we can take that out by taking I out. So I have the square root of 75 times I square root of 75 times I square root of 75. Okay? Now, 75 reduces to 25 times 3. 25 times 3. 25 times 3. So perfect squares we can take out. So what's the square root of 25? It's 5. So I have 5i square root of 3. So this would be 5i square root of 3 times 5i square root of 3. All right? Now, if we multiply the outsides together, we have 5 times 5 times 5, which is 125. And we'd have I times I times I, which is I to the third, right? Now, if the insides, we would multiply 3 times 3 times 3. Okay, we're not finished. We haven't cleaned it up completely yet. So I to the third, let's think about this. I to the third is I squared times I, right? Which is negative 1 times I. So this is really negative 125I times square root. I can take 2 3's out, or 2 times, sorry, 3 times 3 is 9. Well, square root of 9 is 3, so I can take that out. And it leaves me with the radical of 3. So I can keep on simplifying this. Negative 125 times 3 gives me negative 375. I is still there, and it's square root of 3 on there. So now this is in standard form. All right? So remember our patterns with I. Write out each step. Do not be afraid to take space with this, but keep on working on it, and you will get it. Okay, please let me know what questions you got, and we'll see you in class.